All right, so let's go through a few review problems, and then we'll go through some new stuff. Now, this is my disclaimer, right? As I just mentioned, this is not intended to be a review of every single thing that's on the exam. This is just some of the high points that I think a lot of students tend to forget or have trouble with. The full list of what's on the exam is in that outline. So I don't want you to be like, but it wasn't on Wednesday's review. I didn't know it was going to be on the test, right? The outline tells you what's on the test. These are just some problems that I've picked that I see students have issues with in the past. But obviously what you struggle with is not going to be the same as what other people struggle with. Okay, so let's go through these together. Classifying as elements or compounds. What's this one? Element or compound? Element. What's this one? MgCl2. Element or compound? Compound. Sodium chloride, element or compound? Manganese, element or compound? And HNO2, compound, right? Elements and compounds. By now, because you know how to name compounds and write their formulas, I think this question, if it were on the exam, would be pretty easy for you. All right, let's just shout out our answers for this one. We're doing, all of these are mixtures, right? So we're deciding, are they heterogeneous mixtures or are they homogeneous mixtures? Before we go through this, let's refresh our memory. What's the difference between a homogeneous and a heterogeneous mixture? Right, homogeneous mixtures, everything is distributed evenly, and heterogeneous mixtures, uneven distribution, right? So let's go through these. Powerade, sports drink, homogeneous, right? Homogeneous, if you prefer to pronounce it that way. Lucky Charms cereal, that would be heterogeneous. Tap water, well, in theory it's homogeneous. What happens in reality though? It's actually, in reality, it's heterogeneous, right? Because think about it, has to sit in the pipes. And so that creates, my tap water here is very heterogeneous. If you turn on your faucet, yours is going to have more rust in it than that one would over there, right? Because the pipes especially. Okay, air. That one's heterogeneous, right? It's not exactly uniform. The proportions are about the same, but obviously it's not exact. What about brass? Think about like a brass doorknob. Can you see the sections that are copper and the sections that are zinc? No. So what would that be? Homogeneous. Potting soil would be heterogeneous. Jello, either the dry mix or once you've made the product, it would still be homogeneous. And then salad would be heterogeneous, right? So all of this is stuff from like first day, right? We did this, I think, on the first day of class. Okay, do this on your own for a second. Draw the particles in a solid, a liquid, and a gas. I'll pause the recording for a second while you do that. All right, let's go over this one. Drawing the particles in a solid, a liquid, and a gas. So grade your work as if this were, the exam itself. So in a solid, are the particles close or far apart? They're in close proximity. What's special about the solid state? Something special about solid that you don't find in liquids and gases. What? They vibrate only, yes. And is there order or is it disordered? It's order. Look at my models above on the cabinet back there, right? Those are regular repeating arrangements, right? That's what I'm looking for. That's called the crystal lattice. So regular repeating arrangement. So if this is one way that I would accept it, right? If you drew it like this, right? There's one way to draw it. And you could draw several rows if you wanted to. You could draw several rows if you wanted. But we have a regular repeating arrangement. Regular repeating arrangement. Does anyone know what that's called? There's a special word. It's called the crystal lattice. Okay, that's something you only find in the solid. Okay, you're not going to have crystal lattice in the liquid or the gas. So they're in a regular repeating arrangement, right? They're in close proximity. You also could have drawn them if you wanted to draw them like this. Right? If you wanted to draw that That'd be acceptable too. You can draw some layers. You know, draw a layer on top. So we've got the crystal lattice. And then in terms of motion, what kind of motion do you have in the solid state? We've already mentioned it. What is it? Vibrations, right? So we'd represent that, pick a few of them, and just kind of show that they're vibrating. You don't have to draw little vibrations on all of them. Just pick a few and draw it, okay? Show that there is motion, right? There is motion. There's always motion unless you're at what temperature? Absolute zero, 0 Kelvin. Okay, so there's solid. Now in the liquid state, do you have the crystal lattice? No, no. So is it arranged nice and pretty? No. Okay, so they're in close proximity, but there's not any sort of order. Right, random orientation. If you wanted to draw it inside a beaker just as a frame of reference or something, you could. What kind of motion is there in the liquid state? So how do we represent that? With what? Small arrows, right? And again, random directions. Okay. So there's the liquid state. You could draw it in a beaker or something if you wanted to, but that's not necessary. And then what would be the gas state? Are they close or far apart? They're far apart. Is there any sort of order or is it random? Random. All right, what about motion-wise? Big arrows, right. Again, random directions. Any questions on this question, or on this problem? All right, let's go on to the next one. Make these conversions. 83 degrees Celsius to Kelvin, 298 Kelvin to degrees Celsius. So you need to remind yourself what the conversion is between Kelvin and Celsius. If you don't know it, now's the time to commit that to memory. So what's the conversion factor to go from Celsius to Kelvin? What do? Add what? 273.15, right. So we take 83 degrees Celsius, we add 273.15. That's what our calculator gives us, right? Question for you in terms of sig figs, in terms of significant figures. Can we leave all those decimal places? No, right? Because remember, addition, what is the rule for sig figs when we add? It's by decimal places, right? That's the rule for sig fig adding. It goes by decimal places. Does 83 have any decimal places? No. So my final answer can have no decimal places, correct? So what should my final answer be rounded to? Just 356, right? Your calculator doesn't know anything about sig figs, okay? That's why I make a point in pointing this out. If you just plug this in your calculator doesn't know sig fig rules. It just adds them the numbers for you, right? You need to remember, okay, when I'm doing sig figs addition, right? Now there is another way you could look at this. There is another way you could look at this. You can treat this 273.15 as a constant, okay, because there are a lot of constants that we have. For instance, the speed of light is a constant, right? 2.99 times 10 to the 8 meters per second. That's a constant. That's a value that doesn't change. Pi, 3.14, blah, 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 is a constant. Okay, so if you didn't round that, if you did not follow the sig fig rules on this one, I wouldn't count you wrong, because that means you're treating 273.15 as a constant. Okay, but just as a reminder on sig figs, right? Generally speaking, when you're adding, you go by decimal places. Okay, so I would accept it either way in this problem. If you rounded by sig figs and left it as 356, I would accept it. Okay, I would also accept 356.15 here because we're treating this as a constant. Okay, so that's the only example, really, where rounding or not rounding won't hurt you. But for everything else, it will get you in trouble if you forget to round appropriately. Okay, how do we go from Kelvin back to degrees Celsius? Subtract 273.15, right? So 24.85. Again, here's an example where I would accept it either way, okay? Because if you rounded it to 25 because you were saying, okay, I'm following my sig fig rules, I would accept that. If you didn't round it because you're treating 273.15 as a constant, I would accept that too. Okay, so I do have a little bit of leeway. Where I will definitely mark points off is if you forget units, right? Forgetting units is a guaranteed way to lose points. You always have to include units. You can't just give me a number. Do we understand this one? Do we remember this one? Yes? Okay, let's do these real quick. 5 meters. Convert 5 meters to millimeters. Convert 5 meters to, oh, I won't even tell you what that prefix is. You'll have to remember it. And convert 5 meters to, I won't tell you that prefix either. I'll just say K. I'm going to pause the recording real quick. Let's go over this one. Alrighty. Let's review our prefixes, because if you've forgotten them, it's time to relearn them. All right, so the prefix and the little mnemonic I came up with this semester was kale, dinners, cost, me, money, and patience. That's what I came up with. You're welcome to come up with your own if you like something better. K is for kilo, D is for deci, C is for centi, M is for milli, M is for micro, and we use the prefix mu for that, right? That's the Greek letter mu. N is for nano, and P is for pico. So we make a list of tens, 10, 10, 10, 10, 10, 10, 10. What's the value associated with the line? It's not 0, it's 1, right? So here, this one's 10 to the negative 3, then this is 10 to the first, second, third, then what? 6, 9, and 12. Okay, so if we're doing 5 meters, I'm gonna shift my prefixes over here. This one's micro. So I have room to work out these problems. Okay, so I have 5 meters. And so we're setting this up. Now, if you want to do it, if you want to write it like this, so you're using scientific notation, 5 is the same thing as 5 times 10 to the 0, right? Because anything to the 0th power is 1. So if you want to keep everything in scientific notation, just for sake of simplicity, right? 1 is 10 to the 0, right? So 5 times 10 to the 0 is the same thing as 5 meters. Okay, meters goes on bottom or on top? Bottom, I want to get rid of it. And where is meters on here? It doesn't have a prefix, so what does that mean it is? It's base, right? So that means that the number that goes with it is 1, right? And I'm converting to milli. So which value goes with milli? 10 to the 3 or 10 to the 6th? 10 to the 3rd, right? All right, so 5 times 10 to the 0 or 5, right? 5 times 10 to the 3rd divided by 1. So that's what? My final answer is 5 times 10 to the 3rd millimeters. Do we agree? Add 1 sig fig in my original. I'm going to have 1 sig fig at the end. This is the answer. Right there. That's the answer, yes. If you wrote 5,000, I would accept that too. Does that make sense? Just as a frame of reference, what's a meter? How far is a meter? Is it a large unit or a small unit? Right? There's a meter. Right? Meter comes up to right at my belly button. It's very convenient. So if you're the same height as me, probably comes up to your belly button too. Okay. Let's do the next one. We've got 5 meters. Again, if you want to write it in scientific notation, just to keep it consistent, you can. But 5 times 10 to the 0 is the same thing as 5, right? Is meters going to go on bottom or on top? I'm trying to get rid of meters, so it goes on the bottom. And micrometers goes on top. What value goes with meters? What value goes with micrometers? 10 to the 6th, which is the same thing as what? A million, right. So 5 times a million divided by 1. So my final answer is just 5 times 10 to the 6th. And my units would be micrometers. Make sure your answers include units. Okay, if you just wrote 5 times 10 to the 6th, you will lose points. All right, let's do the last one. 5 meters. Meters is on bottom or on top? We want it to go away, so it'll be on the bottom. And kilometers is on top. Value with meters is 1. What value goes with kilometers? 10 to the negative 3rd, which is the same thing as what decimal? If you don't like that exponent, that's 0.001, right? It's the same thing. So if you don't like a negative exponent, that's the same thing. 5 times 10 to the negative 3rd divided by 1. So my final answer is just 5 times 10 to the negative 3rd. My unit would be kilometers. Questions on these 3? If you made a mistake, you see we made it. Okay. Let's move on. Oops. There we go. Okay, do this one. How many milligrams are in 42 kilograms? Let me pause the recording for a second. Let's go over this one. So, if we're working this problem out, I recommend doing it in 2 steps because we're going from milli to kilo. I already erased my prefixes, but I think you still remember them. So we've got 42 kilograms. 42 is the same thing as 4.2 times 10 to the what? 42 is the same thing as 4.2 times 10 to the first, right? 10 to the first is just 10. So if you want to keep everything in scientific notation, that would be how you'd start out. Okay, so we've got 42 kilograms. What we're going to do, if we're going from kilograms to milligrams, I would go kilograms to grams and then grams to milligrams. That's what I would recommend doing. All right, so let's do kilograms to grams. 4.2 times 10 to the first kilograms. Okay, what goes on bottom? Kilograms or grams? Kilograms. And grams is on top. What value goes with grams? 1. What value goes with kilograms? 10 to the negative third. Now when we divide exponents, what do we do to them? Subtract them. What's 1 minus negative 3? Right. So you get 4.2 times 10 to the fourth grams. You can also do this in your calculator if you wanted to do that, right? 42 divided by 10 to the negative third, you'll get the same answer. So now we've got it in grams. We want to convert that to milligrams. So let's take our same answer. 4.2 times 10 to the fourth grams. Now we're going to convert it to milligrams. So what goes on bottom? Grams goes on the bottom, and milligrams goes on top. 1 gram is equal to how many milligrams? How many milligrams are in a gram? 10 to the third, right? 1,000. So when we're multiplying exponents, what do we do to them? What do we do when we multiply exponents? We add them, right? So 4 plus 3, so that gives me 7. So my final answer is 4.2 times 10 to the 7th, and my units would be milligrams. Again, you could enter that into your calculator if you wanted, but I'm just trying to teach you how to be independent of the calculator, right? You don't have to be so attached to it. Just remembering that when you multiply exponents, you add, or you divide exponents, you subtract, you can do the mental math, right? Questions on this one? This is your final answer right here. And that makes sense, right? Because a milligram is a small unit, a kilogram is a large unit, right? Your mass is measured in kilograms. So it would make sense that that mass in milligrams would be very large. All right. Let me take a second and pause the video. You're going to want to round your final answer by 6. All right, let's go over this one. So, again, I make the point of reminding you that your calculator isn't going to be able to round your answer for you. Okay? Your calculator doesn't know anything about sig figs, so your calculator is just going to give you the mathematical answer, and then you would need to round it appropriately. How many sig figs are in 200? No decimal place. 1. That's got 1 significant figure. How many sig figs are in this value? 1, 2, 3, 4, 5, 6. So which value is more accurate? The second one, right? The second one. So my final answer is only as good as my worst measurement, right? So my final answer is it going to have 6 sig figs or 1? It'll just have 1 sig fig, right? You go by the least number of total sig figs. So your calculator will give you out a whole bunch of decimal places, but you've got to round it to 1 significant figure. Okay, so when you put that in your calculator, 200 times 2.14946. That gives you 429.892, right? That's what your calculator gives you, 429.892. If you round that number to 430, that value's got 2 sig figs, right? We can't keep 2 sig figs. So we either round up to 500 or down to 400, right? We're obviously going to be rounding down because we're at 429. So because of this value being so poor, that means our final answer is pretty poor too. Okay, so this is one of the most common mistakes with sig figs. It involves zeros and no decimal. Okay, if you rounded your answer to 430, you would have 2 sig figs. So you have to round it so that you only have 1 significant figure. Does this one make sense? Questions on this one? All right, here's another one, multiplying first and then dividing. We're going to round our final answer to how many sig figs? 2 sig figs. Okay, so 16 is what I got. Do we agree? And then this one's division, 4 sig figs versus 3. So our final answer has 3 significant figures. So 4.55. Now there are no units here, right? So your answer wouldn't use units. Of course, if yours had units given, you would need to also have units in your answer, right? If this was centimeters and this was centimeters, your answer would be centimeters squared, for instance. Okay, so if I give you units, make sure you figure out what the appropriate units are. Questions on this one? All right, here's some more to do. I'm going to pause the recording. See how we did on these. So what's the rule with adding and subtracting? It's not total number of sig figs, it is decimal places, right? So in the first one, we're going to keep 2 decimal places. Do we agree? 8.09. No units, right, because I didn't give you units. If this was milliliters and this was milliliters, obviously your answer would be in milliliters too. Do we agree? Second problem, we're keeping 1 decimal place, 5.9. Do we agree? And then third problem, we're keeping 2 decimal places, so 20.19. Do we agree? Questions on any of these 3? If you made a mistake, you see remade it. Okay, try this one. A substance has a density of 0.92 grams per milliliter. What volume will a 23-gram sample of the substance occupy? Pause the video. All right, let's go over this one. A substance has a density of 0.92 grams per milliliter. What volume will a 23-gram sample of the substance occupy? So before we do this, we need to remind ourselves of some things. First of all, we need to know what's the formula for density. Density equals mass over volume, right? So we know the formula for density. That's something we'll have to know. So density is equal to mass over volume, okay? That's step 1. Now, the density is being given to us, right? Does this value have 3 sig figs or 2? 2. Why is this 0 not significant? It's to the left of a non-zero digit, right? It's like a placeholder. And then this value has how many sig figs? 2. So our final answer will have 2 sig figs. Now we're being asked for volume. So I need to figure out what my units are going to be. So to figure out the unit of volume, what do I look at? Look at the volume unit in density, right? The volume unit in density is milliliters, therefore my answer is going to be in milliliters as well, okay? So we're just going to plug in and do some arithmetic. Right? The density being 0.92, so 0.92 is equal to 23 over V, right? I see students plug in these things backwards all the time. Make sure you're plugging in mass instead of volume, because if you had 23 in the bottom versus 23 on the top, that's very different, okay? So how do I get V by itself? All right, multiply both sides by V. 0.92 V is equal to 23. So divide both sides by 0.92. So volume equals 23 divided by 0.92. Okay, that's how we do the algebra. Are we in agreement on the arithmetic? All right, so now what we need to do is just plug it into our calculator and then round to 2 sig figs. So 23 divided by 0.92 is 25. And then what will my units be? Milliliters. Do we agree? Get the same number? All right. So that's an algebra question. Okay, fill in this chart if I give you that information. And then I ask you also, is this an isotope? So take a second and complete the chart. Let's see if we got this one right. So if I gave you the nuclear symbol, you have everything you need to be able to complete this chart, right? So number of protons, that's just the bottom number. The identity is nitrogen. Even if I just put, you know, a happy face right here, 16, 17, happy face, right? You still should be able to figure out the identity because element number 7, you just look at the periodic table, it's nitrogen. All right. Number of electrons is 7, right? Because protons is equal to electrons. This is not an ion, right? This is not an ion. This is a neutral atom. How do I get neutrons? Subtract what? Right, 16 minus 7. So that's 9 neutrons. And then hyphen notation would be nitrogen dash 16. All right, name and then the mass number. So question, is this an isotope? How do you know? You look at the what? Mass number or the atomic number? Mass number. And you compare it to the periodic table, right? Periodic table has a mass number of 14. This has a mass number of 16. So is this an isotope? Yes, it is. Okay, take a second and do this one. Draw a 1p, a 4s, and a 3d orbital. One P, 4s, and 3d. One P, 4s, 3d. I'll just give you a few seconds to do this one because it doesn't involve any complicated calculations. What is the shape of a p orbital? There are lots of ways you can orient it, right? There are 3 ways you can orient the p orbital. You could orient it along the x, the y, or the z. I didn't specify orientation. This is Intro Chem. I'm not going to specify orientation, so you could draw it horizontal, vertical, or diagonally. I'd accept either of the above. What shape is a p orbital? Looks like an infinity if you're drawing it horizontally, right? Or it looks like a figure 8 or like a diagonal figure 8, right? How do you factor in the value of n? Use what? Just use your tick marks on the axis, right? So if you're drawing it this way, there would be a 1p. Do we agree? Okay, S. What shape is S? Circle, and how do we denote that it's 4? Okay, so we need do we agree? Do your best. You don't have to get out a protractor and draw a perfect circle. D orbitals. There are 5 orientations of a d orbital. Okay, there are 5 different orientations. 4 of them look like a what? 4 of them look like a clover leaf. And then what's the 5th one look like? Looks like a p orbital with a ring around it, right? So you could pick any one of those 5 because I'm not going to specify orientation in Intro Chem. So 3D. That one would be acceptable. Do we agree? All right. I think there are only a couple more left. And we're going to take a mental break. Yes, electron configuration for sodium. I want the full thing. I'm not going to pause the recording for this one because it's not going to take you very long to do. Full electron configuration. if you have to look up in your notes how to do it, you're not there yet, right? Because the exam is not open note. So if you don't immediately know how to do it, make a note to yourself, this is something you need to study, okay? Because you should be able to immediately know how to do it, right? Otherwise, you're not there yet. You need to keep studying. So there are two ways we could write electron configurations. We could use what? Well, I didn't ask for the shortcut here. I asked for the full thing. What are two methods? Diagonal rule is one way you could do it, right? The other way is using the periodic table, right? So either way, you'll get the same value. 1s2, 2s2, 2p6, 3s1. Either way, you'll get the same answer. 11 electrons, right? All your superscripts need to add up to 11. If you're using the periodic table, then by default, they'll add up to 11 because you're just reading straight off the periodic table. If you're using the diagonal rule, you got to keep track and count. Okay, let's skip that one because we just did it. This is the last one. Here's the orbital diagram. I've given you all the boxes. I've probably given you more than you need. Maybe I have, maybe I haven't. You complete this orbital diagram for calcium. So this is how it would be on the test. I would give you the boxes. You would populate them. How many electrons are in calcium? 20, right, 20. So you just start going at where? Do you start at 1s or 4p? 1s, right? And then how many electrons can go in each box? 2, right? One going up, one going down. Those are the opposite spins. And then your orbital diagram should match the electron configuration, which it does. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. The other boxes are just extra, right? Nothing goes in them. Questions on this one? Now notice in this review, there were no questions about ions. There were no questions about ionic bonding, because we spent all day Monday doing an enrichment on that. There were also no questions in here about atomic theory, about models of the atom. There's a lot of stuff that is fair game for the exam that was not in this review. So again, I encourage you, go out to the website, download the outline, and let that be your friend as you prepare. All right, so we're going to stop for here, take a mental break.